Hey guys, what's up? This is AJ of Bridging Code, and for this tutorial, we're going to integrate with two of AWS's popular messaging services, which are SQS and SNS, using Spring Boot deployed through AWS Elastic Beanstalk. For this tutorial, we will build an application that exposes a RESTful API to submit a JSON request containing a list of names that is not yet ordered alphabetically, send it over to an SQS queue, and have another application which listens to the queue, process the message it received by arranging the list of names alphabetically, while at the same time notifying a user through email when a list of names has been received and processed using SNS. Theoretically, this should literally be two applications two applications deployed on different EC2 instances, but for the purposes of this tutorial and to keep things simple, they will just be packaged together in a single Java project and be deployed in a single instance. Um, for those who aren't familiar yet with what Elastic Beanstalk is, I will also talk about that later, but it isn't essentially part of the application flow. Rather, we will use it to easily spin up the EC2 instance where we will deploy our application. So most of you, so most of you guys new to AWS are still a little confused with the difference between these two messaging services, the Simple Queue Service or SQS, and Simple Notification Service or SNS. Some would even think that you could use both for the same purpose, but they are very different. First of all, SQS is poll based, meaning a consumer, or rather a listener, needs to constantly listen to the queue and wait for any incoming message for it to grab and process. SNS is not like this. An application will publish a message on an SNS topic, and one or more subscribers may receive this message or the notification through different protocols like JSON encoded messages via HTTP or HTTPS, for example, webhooks, an email, SMS, or even an SQS queue. In SQS, obviously, the messages are queued while waiting for a listener to grab them. SNS is pub sub. Messages are published in a topic, and any subscriber subscribed to the topic will receive the message in real time. If there are no subscribers to receive a message, it is lost. The messages in SQS are persisted in the queue for a configurable amount of time, while there is no persistence in SNS. Again, if there are no subscribers subscribed to an SNS topic, the messages that are published there are lost. You would normally use SQS to decouple or integrate two different applications which may or may not be from different systems or domains. You would likely use SNS if you want your applications to receive messages in real time or be notified, or if you need to trigger a webhook or for doing some kind of process, for example, when building chatbots. Now, this tutorial isn't really for Elastic Beanstalk. I just want to demo an app that works with SQS and SNS, but we'll cover it just a bit because we are going to use this to deploy our Spring Boot app. In the future, I might post a tutorial that covers purely Elastic Beanstalk, how you can model an Elastic Beanstalk setup using CloudFormation, or how you can use the AWS CLI to deploy with Elastic Beanstalk. So I guess just wait for that. If you're not yet familiar with what AWS Elastic Beanstalk is, it is an AWS service that you would use to easily deploy different kinds of apps coded in Java, PHP, .NET, Ruby, Go, Node.js, or even ones that are contained in a Docker image. You don't need to worry about provisioning your own EC2 instance and creating your own security group. It does this for you. But One of the main features of using Elastic Beanstalk is that it also sets up load balancing and an auto scaling group for you in just a few clicks with minimal configuration. For this tutorial, we're not going to put up a load balancer to keep things simple. And also, I'm just on free tier. I don't want to incur additional charges just for setting that up, only to tear it down later after a short while. So to start off, let us first create all the AWS resources that we'll need. First, let's create the SQS queue where we will send the messages and listen to. For this one, I'll select the standard queue. If you want your messages to be queued up in a first in, first out manner and to get delivered exactly once, you may select FIFO, but for this tutorial, we'll just go for standard queue. I will name this queue bridging code -q. For the configuration, we'll pretty much just go with the defaults. The visibility timeout is that window when a message is received by a listener or consumer. It will not be available or visible in the queue. If the consumer is unable to process and delete the message before the visibility timeout expires, it will again be available for other consumers to receive, so keep this in mind. Then we also have message retention period, which is the amount of time that SQS keeps or persists messages that are not deleted in the queue. If this expires, then SQS will automatically delete the message. Delivery delay is where you set how much time to delay any incoming messages to the queue. If, for example, your consumers need more time to process the messages. Maximum size, maximum message size is where you set the max size of the message in KB. We're also just going to leave it as is. And then finally, we have receive message wait time, which is the max amount of time that polling will wait for messages to become available to receive. If you want to reduce the cost of using SQS by lessening the number of empty responses, you might want to consider long polling and set this for a longer time period. We're also just going to leave it as is. I'm not that worried about the cost since I'll be deleting this queue immediately after the demo. Access policy is set to basic, that's okay. We don't need to enable encryption. Dead letter queue or DLQ is another queue where you can redirect any erroneous or undeliverable messages that keep getting rejected by consumers. If you want to make use of DLQ, you can just enable this, but for this tutorial, we're not going to be using a DLQ to keep things simple. And let's hit create queue. And now that we have created our SQS queue, let's head over to SNS to create our topic. For the type, you have two options, either a FIFO or standard. If you want to receive notifications in the order in which the message is published in the topic, you can choose FIFO. But for this one, I'll just go for standard since I'm not quite sure if FIFO topics are covered by free tier. But normally, if you want to be notified of events in real time in the order in which they have transpired, FIFO might be a better option. The topic name will be bridging code -notifications. And again, we're pretty much just going to leave everything else as default. Let's hit create topic. And once your topic is created, we also need to create a subscription to subscribe to the topic to receive the notifications. For this demo, we would like to receive an email when we pulled a new message from the queue containing the list of names, and another email notification once the list of names has been sorted, so we will choose email. And then specify the email address where you want to receive the notifications. Dot hit create subscription. Once you have created this topic, it should appear in this table, and you will see in the status that it is pending confirmation. So AWS sent a verification or confirmation email containing a link to confirm your subscription to the email address you provided. So you better check your inbox or spam folder for that. Next is we have to create an environment in Elastic Beanstalk where we will deploy our Spring Boot app. But first, let's ensure that we have a role containing all the permissions that we will need. Earlier, I have created the role, and honestly, it took me quite some time to set up an environment at first because I kept encountering permission errors when trying to build and deploy a Spring Boot app with Elastic Beanstalk. So please just take a good note of all the permission policies I've assigned in my EC2 instance role, just so you don't encounter the same series of permission errors as I have before. It's easier to just grab an administrator role to be allowed for any service that your EC2 instance will need, but in reality, you wouldn't really want to do this for security purposes. I mean, it's always best to restrict your users or EC2 instances to what they're only meant to do. Now, going back to Elastic Beanstalk, let's create a new environment. Choose a web server environment. Let's call the application that we will deploy here to be spring-boot-SQS-SNS-demo. And just leave the default environment name it came up for us. If you want a custom domain for your app, you can enter it here and check its availability, but I'm just going to have one auto-generated for me. Let's stay with a managed platform and select Java and choose Java 8 running on 64-bit Amazon Linux. And for the application code, let's just have a sample application for now, just so we could verify it later. If Elastic Beanstalk created the environment for us successfully, we could just upload our Spring Boot app later. Now, before we create the environment, let's go to Configure More Options. And in here, you can see a lot more configurable options, like the type of instance that Elastic Beanstalk will provision for us. It will only be in T2 Micro, since I don't want to break out of free tier. And of course, an application load balancer, which we will not be configuring for this demo. Let's go to Software, and under Environment Properties, let's add server port with a value of 5000, just so we don't encounter any issues later with how Elastic Beanstalk would map out the port to our Spring Boot application. And under security, in the IAM instance profile, let's go ahead and assign the role that I asked you to create earlier with all the necessary policies. In my case, that's my-eb-ec2-role. Let's click Save and create environment. This may take some time to get created. Under the hood, Elastic Beanstalk will create a CloudFormation stack to spin up the resources that we'll need, like the EC2 instance with a security group, an auto-scaling group, and an Elastic Load Balancer if you configured one. If you go to CloudFormation later, you will see a new template created by Elastic Beanstalk. So now that Elastic Beanstalk is finished creating the environment that we will use, Um, let's go to this address and check if the sample application is running. And as you can see, it appears that we have created the environment successfully with the sample app running in it. For our Spring Boot app, I have started with the bare classes that we will be working on. We have the app config, where we will place all SQS and SNS related configurations. We have the message listener class, which contains our listener function that will also process messages from the queue. Here is the message sender class, which serves as the REST controller containing the post method to send a message to the SQS queue. And then we have the names class, which serves as our request object and message, containing the list of names which we will sort later. To make it a little more interesting, I just added, created, and updated datetime fields. For our dependencies, we have the Spring Boot Starter Web to put up a REST API to trigger our Spring Boot app. And of course, the most important one is the Spring Cloud Starter AWS messaging to be able to interact with the AWS SDK to integrate with SQS and SNS. I have also included a special logging dependency so we could easily log in to CloudWatch. This is something I just Googled out, which works well with SLF4J. I have also prepared the logback file that will enable us to log to CloudWatch later and specify the log group name and stream name. So please grab this code. This is also available on GitHub, which I have included the link in the description below. Let's first write the SQS and SNS configuration in app-config. Annotate the class with add configuration to let Spring know that this is a config class. We will define a message converter bean, which is a mapping Jackson to message converter to serialize the name class to string before it gets sent over to the queue. Then a simple message listener container factory bean to create the message listener container, and we set the maximum number of messages we can receive in a single call to SQS, which is 10. The value should only be between 1 to 10. Next is we define an Amazon SQS async bean. Which makes use of the default client to authenticate to AWS. This is why we won't need to put in any credentials here because we will rely on the instance profile configuration, which will be based on the role assigned to the EC2 instance that we'll be deploying into. Next is the queue messaging template bean for us to send a message to the SQS queue. For our SNS configurations, we will define an SNS client, which again will use the instance profile configuration. And a notification messaging template bean for us to send notifications to an SNS topic. Next, we write the code to send a message to the SQS queue. Let's annotate this class with @REST controller and autowire the queue messaging template bean for sending messages. And we write the post method to get the JSON request and send it to the queue. try catch, exception E, return new response entity, string, internal server error. Let's call convert and send from queue messaging template. Specify the queue name, which is bridging code-q, and pass the request body. Then we return a successful HTTP response. Now, let's write the code to listen to our SQS queue. Add component. Let's first define a logger for logging to CloudWatch. Then we auto-wire notification messaging template to send a notification over to SNS. And then the listener method that will poll the queue and process our message. Logger error. Errors occurred. Let's log the list of names prior to getting sorted. Receive. Then we send a notification to SNS by specifying the topic name and the message or content of our email. Erase string. Now let's actually sort the list of names in alphabetical order. Oops, I forgot the third parameter, which is the subject or the email subject. Then we log the sorted list of names and then send another notification to SNS that we sorted it. Lastly, let's annotate this method with SQS listener to let Spring Cloud know that this is a listener method. Set the destination topic and the deletion policy to on success so that the message gets deleted from the queue once it is received and processed successfully without any exceptions. And now let's build the code. What you don't want to do is to build the Spring Boot app without skipping the tests, because Spring Cloud will try to run some tests of its own that requires authenticating to AWS, and we don't really have the time to set that up. You could also exclude the classes under Spring Cloud involved in connecting to AWS in a test configuration class if you plan on writing tests, but we don't have any unit tests anyway, and to save us some time, let's just go ahead and skip the tests for now. And now we head over to our AWS console in Elastic Beanstalk and upload our package jar file, which should be in the target directory of your project. Now this will upload our Spring Boot app and deploy it to our EC2 instance. Now that it's now that it's uploaded, um, let's go ahead and copy this URL here and paste it over to Postman and append it with the path to our REST API, which is send names. Then we pass a list of names to our JSON request. Names, Odin, Thor, Loki, Freya. That is successful. Let's first head over to our CloudWatch logs. CloudWatch, there it is. And as you can see, we were able to create a log group name and some streams based from the ones we specified in our logback file. And there you have it. First, we received the unsorted list of names from the queue, and then we sorted it right here. We also updated the updated at date time field, and it took only roughly a second to sort the list. And finally, we checked the inbox, my inbox, and as you can see, I have received 2 emails. The first one was to notify us that we received the list of names from SQS, and the other is to notify us that we sorted the list in alphabetical order. Before we conclude, I just want to show you the EC2 instance that Elastic Beanstalk provisioned for us. So here it is. This is a T2 micro, and this is where we deployed our app. And if we head over to CloudFormation, you can see that Elastic Beanstalk also created a new stack to spin up our EC2 instance and other resources that we needed or might need, like an auto-scaling group. So that's it for this tutorial. If you have any questions, feel free to drop them in the comment section and I'll do my best to answer all of them. Don't forget to hit like and subscribe, and thanks for watching. Bye.